Welcome back, everyone. Yeah, you're watching Cloud on Air from the Google Cloud team. We really hope you're finding these sessions interesting and useful. We've covered so far today an overview of the Google Cloud Platform. If you missed that, don't worry. We're going to repeat that at the end of the day, so you'll be able to stay tuned and catch that at the end. We've also had a really good other sessions, all of which will be on demand as well. So feel free, if you've missed, to come back and watch those. So we're going to carry on now and drill in to a very key subject in Google Cloud Platform, one that we're particularly proud of, which is around big data. A whole industry is spawned from some of the technology that was invented at Google. So I'm very excited to go through that with you. Now, just a few reminders. This is a live format, so I just want to make sure you remember that if a question strikes you, we'd love it if you would enter that question down below. You can put it in there, and we'll come back to it and answer those questions at the end of each session. Also, we really need your feedback, so please do take the time at the end of the session to put some feedback here. It really helps us refine and make things better. Tell us what you love, tell us what you think we should do better, and we can improve over time. I'm very happy to introduce our next speaker. Tina Gogner is a customer engineer, which means she gets great exposure to all of our customer enterprise projects as a technical lead on those. So she's very experienced in taking us through this very important topic around big data on the Google Cloud Platform.
Hi, I'm Tina. I'm an engineer in the Google Cloud team. I'm delighted to have you join me this morning for a short session on big insights with big data on Google Cloud Platform. So this is an interactive talk and it's aimed at beginners and will be followed by a question and answer session. So we all have a question. What even is big data? It's actually quite a weird concept to be calling data big because data has no size, it has no weight. So have you ever run a SQL query that's taken longer than, say, 3 hours or even 3 days, or simply doesn't even run? Well, I sure have. So this is when we're actually entering a different domain because problems are taking a long time. And they're very complicated to solve with the current technology and toolset that we have. So rather than looking at a problem from, okay, this is how many petabytes or terabytes of data, or this is how many millions of rows of data I have, look at it from the perspective that, okay, I've got a data-related problem. I need to be able to solve this problem. And with the current toolset that I have, it's going to take me 3 hours per week daily. Now, this is when people think, okay, I have a big data problem. So the Google way of solving problem is that we've developed tools and technologies here, and these same problems that may take you 3 days currently, it may take you anything from 3 seconds or a minimal amount of time to solve. So in summary, big data isn't really about size. It's really about how long it takes you to solve a problem. And you may notice that the standard tools don't actually work anymore. So I guess you're facing bottlenecks. And this may be one of the reasons why you're here tuning in today to this talk. So as you know, Google is a big data company. We actually have a history of extracting values from big quantities of data. And that's actually the driver in success behind Google's search engine and ads. We're now actually offering the same powerful research-led technologies that power Google internally to you, and that's via Google Cloud. So I'm just going to go through a very brief agenda. This is a very short talk. We have limited time. Firstly, I'm going to go through the pains and challenges of big data at present. I'm then going to give you a very high-level overview of the big data solutions that we have here at Google Cloud. And that will include kind of options that we have for data warehousing, data processing, real-time analytics, and even some visualization. So what do we actually want from big data? We want to be able to, I'm sure you want to be able to glean those insights that will add value to your business operations or your customer experience. So for example, if you work in banking or government, it's really important to be able to kind of detect any suspicious situations across several data streams. And then it's even more powerful to be able to block that in real time. So credit card fraud, for example. You want to be able to kind of effortlessly scale without the painful overhead of purchasing expensive infrastructure. And actually kind of setting up that infrastructure one by one, so each server going in and setting that up is quite painful. Maintaining the infrastructure when it has continuous software patches can become quite pesky as well. And of course, ultimately, you want to be able to do all of this at a lower cost with restrained budgets. So, what are some of the challenges that we're facing today in big data? Well, I'm sure that as a big data developer, you'll agree with me that experiencing some of these you've experienced some of these serious pains throughout your time. I sure have. So, firstly, data processing pipelines can be extremely arduous to build and come with a really steep learning curve. So, for example, Hadoop MapReduce requires you to adopt a kind of a parallel processing mindset. And this is kind of, you'll have to go out of your way and go and learn that. Secondly, there's many kind of silos of analytical data. So data actually sits within disparate databases and different locations. So that actually makes it difficult to amalgamate and bring together. And then, of course, retrieve fast insights on top of that. So in addition, data accessing may not actually be in the same location. So you may have to bug your DBA for access, which we've all done. Thirdly, it's actually kind of infrastructure and DevOps becomes quite complicated because you need more resources as you're growing. And it's actually problematic when you want to scale on demand, and it's also very time consuming as well. Last but not least, data science tools are generally quite disconnected from data. And that actually adds a whole load of new work for data scientists when they can just focus on their functionality and gaining insights. So what actually gives you a competitive advantage and drives your organization forward is insights, right? And that's one of the main things that you care about. And that's because it adds value to your end users. So, for example, if you're working in retail, you want to be able to kind of gain a full understanding, a complete understanding of how your customer interacts or their profile. And that will enable you to provide a personalized marketing approach for each customer. Or, for example, you may want to identify your top selling product or service and the reasons why. But you're stuck in this kind of mind-boggling whirlwind where you're thinking about performance tuning, utilization improvements, reliability, and kind of handling scalability for growth. And the list goes on and on. So to combat all of these problems, we're now shifting towards a kind of a whole new paradigm called serverless. Now, what does that mean? So serverless means that we actually manage all of your data, your databases, the underlying infrastructure, performance tuning and reliability, and the list goes on again. So it's a kind of a fundamental differentiation of Google's data processing portfolio. You're actually able to infinitely scale up, automatically scale down, and this is all managed for you. So you're only actually paying for what you use at any point in time, which makes it even better and economical. And we're able to spin up VMs on the fly for you, of course, depending on your demand and scale, because we execute your queries or your data processing pipelines all at scale. So what does that mean? You're able to free up your time and really focus on insights and user experience. That's what you're good at. So this slide shows that we have a kind of a serverless platform for all stages of the data analytics lifecycle. So from ingestion, we have tools such as PubSub, and to processing, which is kind of Cloud Data Flow to analysis with BigQuery and Cloud ML Engine. So I'll give an overview of these all shortly. So first I'm going to talk about BigQuery. So BigQuery is our fast, powerful, and fully managed enterprise data warehouse solution. So historically, to Google, what we do is we release research papers. So one of these research papers was actually based on SQL analytics at scale, and that was called Dremel. Now, BigQuery is actually based on top of this paper. And what BigQuery enables you to do is analyze terabytes of data within seconds and petabytes of data within minutes. So you can do all of that using a simple SQL query-like kind of syntax, which means you don't actually have to go out and learn a whole new mindset of kind of parallel or distributed data querying for petabytes or terabytes of data. BigQuery actually also automatically encrypts and replicates your data so that we can ensure that you have secure, your data is highly available and it's durable. So you can keep as much data as you want, and it's very economical as it's a pay-as-you-go basis. So BigQuery actually plugs in really well with kind of getting analytics from one of the services that we have called Cloud ML Engine. Now, machine learning is a kind of a data enrichment tool, I guess, as it helps to enrich your data. Now, Cloud ML Engine actually offers you pre-trained machine learning models in a service called encapsulated as Cloud ML Engine. So there's different APIs available for each use case. For example, we have Vision API, Translation API, and Natural Language Processing API. Now, what the Natural Language Processing API does, as an example, is it allows your users to query data without knowing SQL at all. So, for example, if Ben and Jerry's, if you're Ben and Jerry's, you may want to know how many peanut butter tubs did we sell in August. Now, Natural Language Processing API, what that will do is it will extract the sentiment from that word, that string of a query. It will convert it into an actual query from a programmatic perspective, and it will provide you back with an answer. And this is actually a really extremely powerful and intuitive paradigm that we're moving towards. So it kind of makes Cloud ML makes machine learning super easy for you to execute by simply using an API. So you don't need a data scientist or a stats background. And what Cloud ML is, it's just wrappers around TensorFlow models, which, as you may know, TensorFlow is our open source library for machine intelligence. So with BigQuery, we actually have public data sets that are available, and they're stored in BigQuery. They're made available for you to use. Google actually pays for the storage of these. One of my favorite is Hacker News, which is a data set that contains news stories and comments of Hacker News since their launch. And you can check that out online. So that's all good and well for SQL queries on petabytes of data. But what about when we need more complex queries that require more computational logic or kind of distributed data processing? So this actually brings me on to the second service that I want to talk about, which is called Dataflow. So we released the MapReduce paper more than a decade back, and that actually talks about parallel and distributed data processing. So you can think of Dataflow as the kind of new modernized MapReduce. It actually combines two research papers, one Millwheel and one is called Flume. Now that actually speaks about kind of the problems of MapReduce and how to kind of manually orchestrate and optimize data processing pipelines, which was a slight problem with MapReduce. So Dataflow combines these two together and modernizes kind of MapReduce and allows you to it automatically handles orchestration, optimization of your data pipelines, and it means you don't need to manually do that. Underlying Cloud Dataflow is Apache Beam data pipelines. Now, Apache Beam is an open source SDK, and it can actually run in multiple places. So the data processing pipelines on Beam can run on Spark and also can run on Apex, for example. Now, Cloud Dataflow is a platform that enables you to run Apache Beam data processing pipelines on top of. So Cloud Dataflow is kind of a managed service, and it provides Beam actually provides a unified framework. And so how that works is it's got two modes, two switches. So one is for kind of real-time streaming, and the other is for batch processing. So you only need to, as a developer, write one set of code which works for both stream and batch processing, which makes it really simple for you. So you can have a use case where you have a gaming application, for example, and this gaming application, if your customer, for example, is on the plane, they're tapping away, playing on their phone, on their game, and they all of a sudden kind of go offline because they're in the air. You want to still be able to collect that data as soon as they've landed, when they become online, to then update the leaderboards, right? So that you can put them kind of high up or maybe not. So what Apache Beam enables you to do, this unified programming model, enables you to kind of have a mixture of both stream, so real-time analytics, as well as kind of batch processing as well. So next, we are going to be talking about Cloud Data Proc. So we're actually kind of embracing an open cloud culture here at Google. And if Hadoop and Spark are your current workloads and they're the right solution for your problems at the moment, then that's great. We have a fully managed kind of Hadoop and Spark service available on Google Cloud, which is called Dataproc. It comes with auto scaling, so we kind of spin up VMs for you with Hadoop and Spark on there and fully manage that for you. So you can pretty much lift and shift your current workloads onto the cloud. It's actually a really low-cost solution because it's built by the minute, and you can resize the cluster within kind of less than 90 seconds, which is really, really super fast and great. We have built-in integration with things like cloud storage and BigQuery, Bigtable and Stackdriver, which means that it's kind of integrated within the cloud ecosystem and easier to kind of use data from cloud storage or another data source. So next, we're going to speak about our kind of fully managed real-time messaging service, which is called Cloud Pub Sub. So Cloud Pub Sub is actually designed to provide at least once delivery by storing copies of messages in multiple zones. So it ensures that the subscribers can receive the messages as quickly as possible. Now, it's a global service and it ensures high availability and low latency. So you're dealing with kind of streams, for example, if you have IoT devices, so you have a watch or a kind of thermostat. Now, we want to be able to ensure that these streams are coming in at a good speed. So velocity is key here. So trying to do kind of accurate computations brings a multitude of different issues when you're dealing with streams of data. What Cloud Pub Sub does is it provides a kind of completely serverless real-time messaging service, and it promises high availability. This actually uses Google's kind of private fiber network, and that's how it's able to offer such kind of low latency and high throughput. Because Google's network is actually one of the biggest globally. And it's based on a pay for what you use model. So again, serverless. So as an overview of all of the services that I've discussed today, this is kind of a typical big data architecture on Google Cloud. Now, what we have here is Cloud Pub Sub, which is for kind of the ingestion, and Cloud Storage, which is for storing data. This moves on to kind of, from Cloud Pub Sub, we have our stream pipeline coming in from our Cloud Storage. We have batch kind of data coming in. They both tie into Cloud Data Flow, which is a kind of a parallel data processing model, as I mentioned. And that then ties into BigQuery, which is our analytics engine. Okay, so far, we've actually discussed data processing tools. And you may be wondering, wait a minute, how do I glean insights as a data scientist or a business analyst? As they say, pictures can speak 1,000 words. So we have a service called Cloud Data Lab, and it's a really powerful interactive tool that enables you to kind of explore, analyze, transform, and visualize data and build machine learning models on Google Cloud Platform. So it runs on Google Compute Engine, and it connects to multiple cloud services quite easily so that you can focus on your data science tasks. So it's aimed at data scientists, and it kind of, you can change your figures in real time. So if you're sitting with a colleague and they're asking you to manipulate a certain attribute of data, and you want to see what effect that has on other variables, or what effect that has on an overall picture, you can do that then and there and kind of experiment on the platform. It's actually built on top of Jupyter notebooks. So if you heard of IPython and Jupyter, which is kind of Julia, Python and R, it's built on top of that. It's open source, and it integrates well with our other services. So how about having beautiful visualizations to show kind of senior executives or people that aren't necessarily technical what insights you've actually gleaned from this data. So Data Studio is actually kind of an interactive business intelligence solution. And it enables you to build beautiful dashboards and reports and kind of collaborate and share those in real time. So as I mentioned, with Data Studio, that enables you to, business analysts, to actually create beautiful visualizations, and it's based on collaboration. So just as a recap, we've spoken about a couple of the services on the big data platform at Google Cloud. Now, we're trying to really foster a culture of having an open cloud, and we want to do that by ensuring that you're not locked in. So you can use kind of open source tools on Google Cloud and kind of host them on there. Our serverless infrastructure is enabling you to really focus on your core functionality, and we will manage all of the infrastructure and the kind of operations around that for you, as well as security and reliability. We do understand that security is at the heart of what all of our customers are looking for, because it's ingrained within compliance. So we actually have a team of over 700 security engineers working here purely on security for Google Cloud. And we're continuously bettering, kind of ensuring that we have encryption at rest or encryption on wire and data replication. So what's next? So for more information on Big Data Solutions, just click on the link and you can go to Big Data Solutions on the cloud. And for kind of any online training, we have courses that happen around the world. Some courses are coming up in London, so do check that out. or if you're tuning in from kind of your Nordics or Germany, you can also click on that for any local sessions there. Thank you so much for joining me today. I hope that you find this an insightful overview of the big data tools that are available on Google Cloud Platform, and I'm happy to take any questions from you. Thank you.
Thanks, Tina. Great session. Customers really are loving BigQuery. It's one of the products that draws them really to the Google Cloud. So thanks for taking us through that. Well, I hope you're enjoying this format and you're finding these sessions great. We're taking your questions throughout each of these sessions. So if a question occurs to you, please write them down. If we don't get to them now in this Q&A, we'll make sure we come back and answer them online. So let's just jump on in then. So one of the things that we hear a lot is, with BigQuery, is that every time you're running a query, you know that it's going to be costing you a little bit of money, even if it's a few cents. And there's that feeling of like, wow, the costs could just like run away. So how do you help customers control their costs on BigQuery?
Yeah, that's a great question, actually. So whilst experimenting, it's really easy to get carried away with kind of doing a multitude of queries, and then you're racking up expenses. So there's a number of options on BigQuery, such as quotas and flat rates, which enable you to kind of cap your expenses, and ensure that billing is maintained at a management level as well.
So the quota, you can set how much you want to allow people to spend up to, and it's kind of like a bar tab, I guess, right?
Yeah, pretty much, yeah. Yes, that's correct. Mm-hmm.
Okay, great. And so, these queries are incredibly cheap, right? So, we're talking a few cents for each one, but, people do worry about that. And I see this a lot, actually, customers I've worked with. There's a kind of a feeling of nervousness about letting everybody go at it. So one of the things that we invented last year was a flat rate for BigQuery. So this is a kind of all-you-can-query option. So this way you get yourself a reservation of resources on BigQuery. So you're able to, have everybody just go at it, query all day and all night. It won't make any difference. You just pay the same flat rate every month. So if you're getting to a scale where you really want to kind of control that, that's another great option to have a look at. So BigQuery flat rate as well as using the quotas. And the other great thing is, how does it work in terms of like, who pays for the query? So if I'm a department that holds a lot of data, am I getting charged for everybody across the whole organization using that? What ways can we control that as well?
So you can actually segregate your billing as well, and right. Kind of each department can have their own project, and then manage billings kind of in a more strategic manner, rather than everyone using the same account, and then you're not sure right. who's used kind of what the data science department have used and what the data engineering department have used.
So you can roll those up by departments, and the people using the queries presumably get charged rather than the central IT kind of people.
Precisely, yes. Right. You can segregate that into projects.
Cool, great. Okay, so we talked a little bit, obviously, here about BigQuery, but how does this relate to all the other cloud databases that you can use on GCP?
So BigQuery is actually quite good for, it's great for analytical queries. So if you want to do anything really you traditionally do in a data warehouse, so kind of counts, sums, but it's not necessarily that great for transactions.
Right.
So you could use something like Cloud SQL for that, and that's great for kind of transactional data. And say, for example, you had a lot of kind of read and high amount of reads and writes coming from IoT data, and disparate data sources, so multiple streams coming in, and that's a really, really high kind of read and write frequency. You'd be more inclined to use another service that we have called Bigtable.
Right, so Bigtable is what you want if you've got massive reads and writes.
Precisely, precisely. And yeah, that would kind of, that would be more suitable for that case.
And how do you, the different ways to get the data into BigQuery, isn't there? how do you cope with that when you've got vast volumes? Take like an IoT scenario where you're trying to ingest a lot of that data. How do you go about dealing with that?
So, I mean, there's a multitude of options there. One of the most pressing, and I guess one of the easier options would be to use cloud storage. You can think of that as kind of your on-premise data lake, and you can put data into there, and it's a relatively economical in terms of placing your data in there first, and then you can use Cloud Pub Sub, as I discussed in the talk, for kind of real-time streaming, ingestion of that data.
And that bit's handled with Pub Sub, but you can query the data either just in GCS, not doesn't always have to be in the BigQuery store as well. You can federate out to use the GCS store as well. So
yes, precisely.
It gives you a lot of flexibility.
So it's very kind of interconnected, and you don't really need any kind of APIs there. It's all kind of connected within.
Superb. So, okay, so let's think a bit about queries together. So what kind of queries? Obviously, BigQuery is phenomenally quick, scanning petabytes in seconds. I mean, it's insane. But, are there certain types of queries that, you'd want to avoid that aren't actually optimized in BigQuery? How do you get that wrong?
A great question, actually. So you probably don't want to kind of steer away from queries that have a large number of joins. So the data ideally needs to be denormalized, and the fewer tables the better, so that you can kind of BigQuery works at its optimum when there's kind of fewer tables.
Yeah, you do see customers actually using SQL itself to kind of prep the data inside BigQuery, so to denormalize it and improve that kind of thing. Do you see customers using that method for ETL, or at all, or do they have to use some other product outside of BigQuery?
So many customers do actually do tend to use kind of SQL to perform dedupe or merging.
Right.
But again, BigQuery is not really optimized for that. You can use other tools though, and they might be a better fit. So there's kind of data prep, which is for another one of another service available on GCP.
What's data prep?
That kind of enables you to do data wrangling, data cleansing, and it actually generates data flow code behind the scenes. So that's kind of one option, which is data prep, and there's also data proc, which of course you can
right, if you want to kind of batch process more complex things, right, with
kind of like Hadoop and Spark,
sure.
And then there's data flow as well.
Right. Yeah, I have seen customers using, if you've just got kind of like a simple SQL transformation, they can actually just use the power of BigQuery to do that very quickly without the data ever even leaving the store. So, yeah, so good to see. So there's different kind of tools, using the right tool for the job. Fantastic. Yeah. Let's think about, customers moving to BigQuery. Are they? Do you find people are using batch to get the data in more, or are you seeing customers using streaming as well? How do you see that balance between the two?
So you can actually kind of there's a mixture, right? So with data flow, as I discussed earlier, you're able to actually ingest data via a unified programming model via Apache Beam.
Right. So
you can stream data in via batch processing or real time using one kind of unified programming model.
So if you've got data that's running like weekly, you can bring that in maybe in a batch way, and then would you say that if data's coming in real time, maybe that's a candidate for the streaming method of getting the data in?
Precisely, yes. Yeah. And something again, PubSub would be really good for something like that.
Right. So I think that's about all I think we've got time for now. We're going to have to move on to some of the next sessions. Tina, I want to thank you very much for your time and taking us through that. And I hope you get time to play around with BigQuery and start to get use of it. There is actually a free tier, right? There's it's something that everyone can just start using right away.
Yes, precisely. So BigQuery has kind of public data sets that Google host on BigQuery that are available. So I know that NASA and New York City Bikes and Hacker News have data sets on there. You can go in and there's a kind of, the storage is paid for via Google Cloud, and then queries up to a certain level are kind of covered.
That's a great way to get started, isn't it? Use a public data set, start throwing some queries at it, see what kind of results you can get. Great for hackathon kind of style things as well. So yeah, great. Well, thanks again. I hope you found this really useful, and please stay tuned for more Cloud on Air. Thank you.
Thank you.